Okay, in this section, we're actually going to be taking a lot of the information that we've learned over the last couple of sections and compiling all of that together in order to help us get a rough sketch of the particular function. So the things that I have listed here will be the things that you need to find or determine about each of the functions. So I'll just quickly run through this. You'll just need to write this list down to have to refer to. So first of all, you need to make sure that you identify what the domain of the function is. You'll want to find the first derivative. Now, from the first derivative is where you can determine, remember, critical numbers, increasing, decreasing intervals, your extrema, that'd be your maxes and your mins. So all of this would fall from or follow with your first derivative. Then once you find your second derivative, you'll do concavity and points of inflection. And then you need to determine if the function has any asymptotes, and that could be vertical, horizontal, or slant. And then also determine if you have any intercepts. Of course, that would be your x and your y intercepts. And then, as I said, you're going to use all of this information in order to graph the function, just to get a rough sketch of it. All right, the first type of function that I want to look at is a polynomial function. And you notice that I've made the note here that a polynomial function has no asymptote, so that's just an important thing to remember. So when we get to that particular step, I know not to even worry about locating asymptotes. Okay, so first of all was domain, and the fact that this is a polynomial function, you should remember, because this has come up numerous times, your domain of a polynomial function is going to be negative infinity to positive infinity. So there's not going to be any restrictions there. Okay, so first thing, well, that was the first thing on the list. Second is your first derivative. Of course, this is just going to be power rule. So 12x to the third power minus 12x, and of course the derivative of your constant is 0, okay? All right, now from here is where we're going to determine our critical numbers, and critical numbers are going to cause your function to be equal to 0 or to be undefined. Of course, this being a polynomial, it's not ever going to be undefined. We just need to find out what makes it equal to 0. All right, so if I set this equal to 0 to solve it, I can do so by factoring, and I have a common factor of 12x. So if I were to factor this from each term, I'm left with x squared minus 1. So therefore, I would have 12x is equal to 0, which would give me x equals 0. And then x squared minus 1 equals 0. So that would give me x squared is equal to 1. So x is equal to plus or minus 1. Now, these are going to be the values, remember, that you need to put on your sign graph, or these critical numbers, and we're going to be able to use our sign graph to determine, if our function, or where our function's increasing, decreasing, and the extrema. Okay, so make your sign graph. Of course, this is what was referred to as your first derivative test when we were finding extrema. So you're going to be using your first derivative to figure this out. Okay, so I have negative 1, 0, and positive 1. Okay, I need to pick a test number in each of those sections. So like I could use negative 2, negative 1/2, positive 1/2, positive 2. Now you need to substitute these test numbers, remember, into your first derivative. So that's why I have the f prime labeled over here. All right, so with this section that goes from negative infinity to positive infinity, if you substitute the negative 2, like I said, here into your first derivative, then you're going to get something that's negative. Okay, then if you substitute in the negative 1/2, so that's going to be, of course, this interval from negative 1 to 0. Okay, so that's going to give me something that's going to be positive. Okay, and then from 0 to positive 1, if I substitute 1/2 in, then that's going to give me something that's negative. And then last, if I substitute 2 into my first derivative, that's going to give me something that's positive. So that would mean that this is a section that's decreasing, increasing, decreasing, and increasing. Okay, so let's go ahead and let's write down our intervals of increasing and decreasing. So for increasing, you would have, of course, that would be, you know, the two parts that are positive. So this would be from -1 to 0. And then we would also have 1 to positive infinity. And then decreasing, of course, that's going to be my negative sections. So that's going to be negative infinity to -1. That would be this section or this interval. And then I'm also decreasing from 0 to positive 1. Now, also from here is where I can determine maxes and mins. And the fact that I'm decreasing in this interval, and then once I get to the -1, I change and increase. So my graph's going to be coming down and it's going to curve and go back up, which means right here at the -1, this is going to have to be a minimum value. Okay, so then here I have a section that's increasing, and then once I reach the 0, it decreases. So right here at the 0 would have to be a maximum value. And then decreasing and then increasing. So again here, I would have to have a minimum value. So we need to locate those actual points because they are actual points on your graph. So at the -1, 0, and the +1, we need to substitute those values actually back into the original function. Okay, so let's just start with f of -1. So remember, you're substituting, like I said, that back into the original function. So if you were to substitute -1 here, then you're going to end up with a -4/3. And then if you substitute in 0, at 0 you're going to get the 5/3. And then substitute in the +1. So at +1 you're going to get a -4/3. Okay, so remember this point, the -1, -4/3, that's a min. The 0 and the 5/3 is going to be a max. And then +1, -4/3 is going to be a min. Okay? Now, that's all the information that we're going to be able to get from our first derivative. So what we'll be ready to do now is to find the second derivative. And that's just going to be power rule again. Okay, so using your power rule on your first derivative, you'll have 36x squared minus 12. Okay, now you're going to do the same thing here as what you did with your first derivative. You're going to need to set this equal to 0 and find those values that would equal 0, that would cause it to equal 0. You can factor out a 12. Of course, you're not going to set just the 12 equal to 0, so you take your 3x squared minus 1, set this equal to 0. So I would have 3x squared is equal to 1. So x squared would be equal to 1/3. Therefore, x is going to be equal to plus or minus 1 over square root 3. Now, if you choose to rationalize that, that would be fine. but it's not something that you would have to do. Okay, so now you're going to do a sine graph, of course using your second derivative this time. And we'll flag these numbers off. So we'll have negative 1 over square root 3 and positive 1 over square root 3. Now, in picking a test number this time, you know, you might want to get the decimal approximation. Actually, of course, negative 1 divided by square root 3 would be about a negative 0.6. So that would mean that I actually could use, say, just negative 1. Of course, in between the negative and the positive would be 0, and then I could use positive 1. Now, this is your test with your second derivative. So you need to substitute these test numbers into the second derivative. So you've got to plug it in here and see if you get something that's positive or something that's negative. So if I plug in negative 1, then that's actually going to give me something that's positive. If I substitute in 0, I'll get a negative, and if I substitute in positive 1, then I'm going to get a positive. All right, so what that's going to indicate that I have, remember here we're determining concavity. So here this whole section is going to be concave up, this section is going to be concave down, and this section's concave up. Okay, so let's list out what we found for concavity. So concave up is going to be negative infinity to negative 1 divided by square root 3. And then from positive 1 over square root 3 to positive infinity. And then concave down is going to be negative 1 over square root 3 to positive 1 over square root 3. Okay, now also from here is where we need to talk about the points of inflection. And if you remember, points of inflection is where your concavity changes. Okay, so points of inflection, of course my concavity changes here and here. Now these are again actual points that you have you know, on your graph, so you will need to substitute these values back into the original function. So you would substitute in, first of all, negative 1 over square root 3. Like I said, this is going to go back into the original function. If you substitute that back in, you're actually going to get 0. And then if you substitute in the positive 1 over square root 3, then you're also going to get 0 there as well. So that would give me these 2 points. Okay. Now, I mentioned next on that list was asymptotes. Of course, as I said, this is a polynomial, so therefore you're not going to have any asymptotes with a polynomial function. Now, y-intercepts, x-intercepts, actually since your y value here is 0, these are actually your x-intercepts. You know, sometimes it is and sometimes it's not. That just kind of varies from problem to problem. So there actually wouldn't be any need to find our x-intercepts. We do just need to locate our y-intercept. So let me squeeze this in down here at the bottom. Now, if you're finding a y-intercept, remember you're going to substitute 0 into the original function. So again, take your 0 back to the original function, and if you substitute it in, what you're going to end up with is the 5/3. Okay, so now what we've got to do is actually take this information and do our graph. Okay, so first of all, what you're going to want to do is actually plot all of these points that we have found. All right, so if you start plotting the points, first of all, let's say we had -1 and -4/3. That was like doing the maxes and the mins. And again, you can just kind of, do approximations with these fractions. So at -1, I have -4/3. So that would be somewhere along in here. And then at 0, 5/3. Okay, so at 5/3, 1 2/3, so somewhere around in here. And then +1, -4/3. Okay, so even though, and I didn't catch this a while ago, and you may have, actually, of course, the fact that you had the 0 here as your x coordinate, I mean, that verifies for sure that that's also your y-intercept, which is the same thing we ended up with down here, okay? Then we also had the x-intercepts. Now remember, the 1/√3 was about 0.6. So if we were to plot those points, so -0.60 and then a +0.60, okay? So that's going to give us enough points. Now this is where you've got to think about your increasing, decreasing, and concavity. So if you look at your increasing and your decreasing, the part that starts at -infinity, see, is decreasing. So that means this is the left, okay? So you're going to decrease from starting on the left to x equal -1, okay? Of course, right here is the point where x is equal to -1. So you're going to decrease until you get to that point. Okay, and then at the -1, see, from -1 to 0, so -1 to 0 is where we increased. So you're going to pick up your x-intercept right here, and then you're going to increase. Now, remember, this was actually a maximum point, so you know that it's got to curve and come back down because that was our maximum. And then we changed to an interval that's decreasing, and then we change to an interval that's increasing. Okay, and I know you've got a graphing calculator to kind of help you out with this, but like I said, if you just go back and look what you found, see, this was from here to here, we said was decreasing, and then we were to increase, and then decrease, and then increase. Now concavity, like if you were to check it, remember it started concave up, so actually to this point right here. So looking at this portion of it, that would be the portion that's concave up. This is the portion that's concave down, and then starting here at this point, this would be concave up. So always, halfway between your concave down and concave up, remember, are these points of inflection.